a system approaching perfection.
We'll walk deeper into the belly of the beast if it means I'm able to further limit risk.
And welcome to the Digital Cash Evolution here in Phoenix, Arizona today. This is Danny. I'm here with Doug. He's been helping me out with a lot of getting some information out to new people in cryptocurrency so you don't go the wrong way. We want to give you information about some of the local meetups, where to find ATMs so that you don't have to end up on the wrong exchange and whatever. We don't want you getting ripped off, all right? There's no need to hire somebody else to go and buy your coins for you. We'll let you know all that. And you can come out tonight, actually, and meet us at, go ahead, Doug, and give us
at the monastery at 4810 East McKellips Road in Mesa this evening. We're doing an intro to Bitcoin class with a Q&A. It's really designed for the newbies and people to come out and get their questions answered and, learn about some of the basics of crypto.
And if you're new and you show up and you don't have a wallet on your phone, let us know. We'll set you up with a wallet, and I'll give you some Dash if you come out and see us tonight. Is there any Bitcoin available?
Sure.
Is there an ATM? Will there be an ATM there on site? Or?
No, we're not going to have an ATM with us on site. We do operate ATMs, though. We can give you the locations but we can sell directly to you, so we don't need an ATM there. But
there's how many here in Phoenix? Seven.
5 in town of ours, and one in Sedona and one in Flagstaff, so 7 in Arizona total. So
there's lots of ways to get into cryptocurrencies, and Doug is also going to be adding new cryptocurrencies here in the near future to the machines that he has. And there's this one very special machine that's going to be showing up at Classic Crust Pizza here in what's the address over there? Do you know?
They're at Cave Creek and Cactus Road. I think I want to say maybe 2310, but either way, it's northeast corner area of Cave Creek and Cactus.
Yeah,
Road.
just look it up on the map.
Yeah.
Classic Crust Pizza. The guy takes all kinds of cryptocurrency over there for his food and beer and whatever. But this new one is called Vault Logic, and it will sell you multiple coins. I think it's got Bitcoin, Bitcoin Cash, Litecoin, Dash. I think they're adding Aetherium. It's got multiples, and they're going to add a bunch more. And it has all different kinds of services, as well as just a traditional ATM built into this machine. So it's like a one-of-a-kind machine. If you're interested in crypto, you got to go see this machine just because it's really cool. But if you're trying to learn how to get into it, this is a great place to go. And definitely come out to our meetups, like I said, and learn what you can so you don't get taken by some scammer, because there's a lot of scammers out there. Let's face it, anytime that something has value, what happens? The scammers show up. So you really have to be careful. But how do you know? If scammers are showing up, then obviously it has value. So you should definitely start paying attention to this technology. Don't get left behind like the guy that we talked about. What was it? Brian Gumbel talking about?
Yeah.
What was it? 90 whatever. Talking
Early
about,
90s.
Yeah, talking about what's the little @ symbol on the email there? AOL. What's all this internet thing?
Yeah.
Well, this is cryptocurrencies are in that same stage right now. So this is if you want to get in, you should go ahead and get in now. Just learn about it. Don't go investing or anything, but learn about this now so you don't get left behind, because I think all of the financial system is really going this way. So we need to pay attention to this. And also, we do have a special guest that's in studio with us who we may need a translator, because this guy is just far and above, our level of technology. And sometimes when he's telling me how his technology works, I'm like, what? It's just, so we'll have to ask him to slow it down a little bit, And go ahead, if you have a question, give us a call at 602-277-KFNX. That's 602-277-KFNX. I don't know. I'll ask my producer in the break. Maybe you can leave a phone number and we can text you back with some Bitcoin.
You can also tweet us at hashtag PHXCrypto. We're going to follow that stream, and if you have any questions that come in, we'll address those. We're also live streaming on the Crypto Show Facebook page and the Phoenix Crypto Facebook page. So if you search those, you'll find the live stream. If you post any questions on that live stream, we'll take those as well.
Yeah. So let's also talk about Phoenix really is kind of a hotbed for cryptocurrencies. There's two of the major best innovative cryptocurrencies that are out there today are actually here in Phoenix, and that's Dash and Nexus. And the creator of Nexus is actually sitting in studio with us, so we'll get to pick his brain on what Nexus is and what it offers, and just some of the hurdles that we have to overcome with technology these days.
And for those just tuning in right now, let's go ahead and kind of cover a bit of a basic definition of this digital currency, this crypto that we use. Bitcoin and the others like it, other cryptocurrencies are a cryptographically secure way of transferring value over the internet. So what that means is Bitcoin and cryptocurrencies have the potential to disrupt the financial system in the way that the internet disrupted the publishing industry. So if you look at in the past, nowadays any Joe Schmo can write a blog and bypass, without needing a publisher to get a message out there. So cryptocurrencies kind of do that for the transfer of value. So now you don't need a bank to transfer money globally.
Right. I mean, look at YouTube. That's disrupted the television industry. I mean, some people's YouTube channels have more viewers than national TV channels. So.
Yeah.
Let's jump in with Colin. Colin, go ahead and introduce yourself and tell us a little bit about Nexus. I know we're coming up on a break, but
So Nexus has been around since about 2014. I'm just sitting back and observing some of the hurdles that we have technologically in the systems and developing new architectures, and then engineering that in order to make cryptocurrencies more easy to use, make it so that people can actually scale with it and utilize it, and then also making the smart contracting engines very easy to integrate for different businesses. So we're developing right now the Tritium update, which is a major step towards the Tau framework, and it's got a pretty interesting stack in there. Our white paper's out, and then Nexus is Amin, and then Obsidian unlocking the three-dimensional chain. So we can break down kind of the layers and what they mean a little bit later, but we're looking to help kind of bridge some of the disconnects that we have in the current industry in order to make it more usable for the everyday person.
Right. And so what got you into kind of technology? I know your dad worked with where?
Elon Musk. He co-founded SpaceX.
He co-founded Space. Oh, yeah. So, his dad. He just co-founded SpaceX. No big deal. So, yeah, the guy comes from a little bit of a tech background. So, I think what he has to say carries some weight here, and we should definitely listen to what he has to say. What are some of the things that you want to, some of the problems that you're trying to solve with blockchain?
Ease of integration and ease of use, and then also a higher level of reliability for merchants, and then an ease of development for smart contract developers, and then also an integration of development and business use cases to kind of, there's a I guess you can call it developers sitting at the top of the pyramid type thing happening, and the technology needs to mature more by actually integrating, connecting with more of the businesses. So that's a big part of it. I mean, how I started was just learning and figuring it out, and
just being a geek with computers.
That's how we got here. Yeah.
Somewhere.
Yeah. So.
All right. Well, Doug, do you have any other information about?
We'll just remind them to come out to this evening and see us at the monastery in Mesa, 4810 East McKellips Road.
What is your plan? You need to take back the power from the dirty bankers, man. Screw those guys, right? And while you're at it, man, if you want to learn how to take back that power, go ahead and give us a call at 602-277-KFNX, and the producer will take your number, and we'll give you a text back, and we'll set you up with a Bitcoin wallet. And I would recommend the Edge wallet. It's a very simple wallet to download, and you can get multiple coins on that wallet. If you want to get even deeper into that with even more multiple coins, then maybe Coinomi. But if you're just starting out, go ahead and try out that Edge wallet and give us a call here at the station. Leave your number, and we'll give you a text back, and I'll set you up with some Dash. I don't know. Doug might set you up with some Bitcoin, and definitely come out and see us tonight at the monastery. And what's that address again,
That's
Doug?
4810 East McKellips Road in Mesa.
East McKellips Road in Mesa. Well, do you have anything else before we get back to Colin?
Yeah, let's just expand kind of on that, the earlier what I was talking about with the transfer of value over the internet. That can sometimes be in somewhat of an abstract phrase or term, transferring value over the internet. So the transferring value over the internet, when we first discovered, or the internet came out, and we were able to freely transfer information over the internet. The first obvious application was email. But at that time, we had no way of picturing what smart people would eventually utilize that type of technology for. We couldn't have envisioned social networks and all of the things that people built on top of a core technology. So the transfer of value is a protocol. It's a core technology that is the blockchain, and we don't even know yet what different creative people are going to build on top of that. So for when I say the transfer of value, most people think of Bitcoin and blockchain as digital currencies. So we use it to the first most obvious application is currency or money, in the same way that email was the first obvious application of the internet. So the transfer value can take so many more forms than just currency. And so Nexus is one of these that's thinking outside of the box, thinking beyond just currency and tackling some higher level problems.
I know, like some of the stuff that he's talking about that he's wanting to solve with Nexus, it makes, kind of the original Bitcoin and everything look like AOL with the dial-up modem and the picture taking 3 weeks to come across. I mean, some of the stuff he's talking about, I'm just like, wow. Let's get into one of those things like CubeSats. Why CubeSats, and what does that solve?
Well, so
and what is a CubeSat?
A CubeSat's kind of, think about it like computers back in the day used to take up full rooms, and then they got small enough to fit in everybody's house. The same thing with a CubeSat. It's a computer that's very small that you can actually put up for a cheap cost. And what it allows you to do is put satellite technology in everybody's hands. So our goal of the Cube satellites is to give more coverage to people around the world, because there's about 5 billion people in the world that can't access these cryptocurrencies because they don't have access to the internet. And then the other thing is developing a model for a distributed satellite constellation, just like ISPs relay traffic for one another, but they all control everything that happens. What we can do is we can have cross-link protocols that are standardized between all these satellites so they can interoperate. And then you can join that cloud or that mesh network up in low Earth orbit. And what it allows you to do is be more resistant to censorship and have easier access for anybody around the world instead of relying on all of the cabling that they're having.
So this is kind of the first stages of you taking the internet away from Big Brother and actually giving it to the public.
That's the plan.
Free and open internet to everybody. And it's going to start off on a small scale, just, very small, just for transactions of Nexus and maybe texting and things like that. Yep. But then it will grow just like the internet and everything else grows.
Mm-hmm. I got a question. How many satellites do you think it would actually need to have up there to take over, say, the root name servers of the internet?
Well, it really depends on what type of frequencies you use. I mean, we're looking into more optical so that you get higher bandwidth, but I'd say a few hundred depending. Well, but you'd want probably thousands upon thousands to add the redundancy for it. But the way to do that is not for one singular company to do it, not for us, but us to help build that model and then develop working groups, kind of how the internet works, where there's the IETF, which is the Internet Engineering Task Force, and they standardize all the protocols. That's how we have all the crypto that we build blockchains on. The similar type of thing, if these satellites can all talk to one another, then we all share and route, and so that multiple companies can start building up around that and deploying these. And then you create a bigger and bigger coverage, and then it's obviously more distributed because it's not owned by a single party.
Awesome.
And it's not like you have access to any way of doing this, right? Your dad works for SpaceX. But how does this differ from what Elon Musk is doing with
Elon's putting up an ISP in the sky. And so, I mean, that's an internet service provider, and you have to connect through their satellites, so it's centralized to their specific company. What we're doing is we're working with Vector, which is a small rocket launch company. And what they're doing is they're deploying Galactic Sky, and we're deploying our own satellites, and then working with other various projects in order to create that standard and then put up ours and figure out that model and then design the economic incentive for it as well, just like there's an economic incentive to run a node when you're a miner or things of the sort, so that more and more people will begin to do that and it builds itself.
Right. And the economic incentive, of course, for Elon Musk is to sell internet to everybody with these satellites. Will your system kind of offer internet to users of the Nexus network, or I mean, will you need to be a Nexus user to do this?
I would rather it be agnostic, and not just based around Nexus. I'd want it to be used for anybody that wants to really contribute to it. So I see multiple blockchains being able to contribute and use that space, not just solely upon Nexus.
Awesome. All right. You want to let's talk about Nexus then a little bit. So how did you decide to come up with Nexus, and what is it that you want to solve there? And then we can get into Tritium a little bit later. But
Yeah.
I mean, like a 3D blockchain. A blockchain.
My eyes glaze over.
Yeah, I'm like, I don't even know where to go with a 3D blockchain. A blockchain itself is hard enough to understand. Can you explain how a blockchain works? Just the typical,
the 2D.
yeah, the 1D blockchain,
The
maybe.
1D.
So the blockchain, what it really did is it solved the two generals problem with Byzantine fault tolerance. So what that means is if you have two generals and they are trying to communicate a message, you don't have a definitive form of truth. And so one could be malicious, and then if you don't have a way to detect that maliciousness, then a distributed network does not work. So a blockchain, really what it solves is it puts a cost using proof of work and saying that the proof of work is therefore the truth. So in a simple sense, a blockchain is a form of a truth box. And so what we can use that truth box for is the ledger of events of, let's say, financial transactions, which allows us to securely transmit and know that I can't spend the same money twice with you, and you solve that double spending problem. But it's a linear data structure. If to not be too technical, it's every block, think about it, is checksum. So what a checksum is it's basically a hash of all the data, so that if you change any of that data, you break that hash. And so in that way, you can't alter any of that data that's been there. So since it's done through proof of work, it basically weights that checksum down so that in order to be the validator of truth, you have to have an incredible amount of resource. And so it makes it very difficult to attack. So every block is linked to one another, so that if I tried to change a transaction 5 blocks ago, I'd have to redo that proof of work. And the probability significantly decreases that I would be able to do that every single block on the chain, so that you get to the point where there's a 51% attack that is the person that is able to take control of that consensus. So it creates a higher resistance to being co-opted or taken over by any sort of central party, and allows us to exchange data essentially across a global network.
Awesome. Like how does it actually work? So the blockchain is the first block is the Genesis block, and then every transaction that happens every 10 minutes is bundled into a block. And what you're essentially doing is you're going back to root 1 and then starting all over every 10 minutes, right?
Root 1.
You're going all the way back to the very beginning. Each time the block, every 10 minutes, you're resolving the whole blockchain, correct?
No, you're just adding a new block onto the end of the blockchain. You're appending to it.
You're appending to it.
Yes.
Right, but the transaction goes back to the very beginning,
Just
right?
the hash.
The hash, okay.
Well, it depends on what transaction you're talking about. I mean, the Genesis had one Coinbase transaction. The next block had another Coinbase, and that's what unlocked the coins. And then that has, I mean, if we want to get technical on the UTXO model, you have to claim that output as an input into a new transaction to prove that that coin came from somewhere. And that transaction is then included in this next block, which is appended. And the hash of that transaction, which is the checksum of it, becomes your transaction ID that is then hashed into a Merkle tree, which then becomes a part of that block header. And then that is what is checksummed, or that is what is worked on by a miner in order to weight that data enough where they prove in asymmetrically that a certain amount of work was done, but any node can verify it very easily.
So so proving this value, that's how you're backing the network, right? The ability, right? The proof of work is what gives Bitcoin its value, because what would it cost to change that proof of work?
That's part of it. Yeah, the electrical cost to create the currency. Yeah.
Yeah, so what's exciting about this is you can actually hand a digital version of cash over the internet.
And we'll be right back. All right, everybody. Welcome back to the Digital Cash Evolution. Go ahead and give us a call if you're wanting to get some free coins. You set up your wallet with the Edge wallet. Go on to the Play Store or whatever, iTunes, whatever kind of phone you got, and check out Edge Wallet. Download that. Give us a call here at the station at 602-277-KFNX, and the producer will take your number and we'll give you a call back and set you up with some coins. And let's get back into it. We're talking with Colin Cantrell, who is the creator of Nexus. And I asked you a question actually earlier, and I wanted to get back into that. So Microsoft took over GitHub. What does that mean for cryptocurrencies?
I think any statement on that right now would be an assumption. We don't know yet. Maybe they might start censoring. Maybe they just want to get on it. I think a lot of people are going to probably move away from that. But I mean, I think the biggest thing, at least what it means to me, is that I think it outlines the need to have a little bit better of a code maintenance system. Most people think Bitcoin is Bitcoin Core, which is just a GitHub repository and an organization there, and that's where everybody references for code. So repositories like GitHub, they were originally just to streamline developers, but I think we're going to see more and more potential issues coming with this. And the Microsoft thing, I think, is possibly something for people to start thinking about and saying, well, do we really want to have this code here? And then how do we decentralize or distribute the code repository?
I mean, exactly. We're talking about decentralization. You're talking about putting up CubeSats, and here's Microsoft trying to take over, GitHub.
Yep.
So obviously the powers that be are trying to stop decentralization, and here we are out here trying to, make it expand. Go ahead.
Well, so, I mean, on the comment on that, I would say, yeah, there's certain aspects of course, they're going to try to take it over because it threatens our system. I mean, if we've seen certain things with the United States, that kind of happened with the federal government, or good things, they always, like as Ernie says, if they can, they will. So,
right,
I mean,
right.
what are the weak points? What are the fail points? What are the central points? And the code repository in development is a central point. It can be co-opted. And, seeing Microsoft taking this over, I think it's going to make people start thinking about it and saying, well, what do we do about this? Do we move to GitLab, or do we try Bitbucket, or do we try our own hosted Git? But then again, that's still centralized if the development team is the one that controls it. How do you make it so anybody can collaborate, but you still maintain the quality of the code through pull requests? Because you don't want anybody to just type hello world into the code. You'd want to make sure it's good code, but then how do you make sure that doesn't just get concentrated into a few hands?
Would Nexus, with their new technology, have a solution for this?
I mean, I have some ideas, yeah. I mean, I've thought of, there's a couple different ideas. One of them which main consensus rules, let's say block size. What if that was a transaction that was read, like a UTXO set, and a constant was signed off on developers that were, let's say, ratified by the network, and you have a better voting system? Or what if we utilize the blockchain as a form of storage mechanism, and every commit is a transaction that contains the data of the code changes, and so when you do a git pull, you're actually pulling from all of the indexes that have all of that code based on the commit history. There might be some options with that. I mean, we're not looking at building use cases like that just yet, because the ledger itself needs to be capable of scaling that. It's like building something, an upside down pyramid. If you have a small foundation, it's not going to hold the weight of everything else. So that's something we're going to explore in the future, definitely, and possibly explore GitLab or self-hosted Git. But I think the future is very possible, and I think some sort of automated development on chain could be a possible solution.
I know. It's like the more they push back, the more, these cypherpunks just come up with 100 different solutions. So I think, they're trying to fill
things.
Yeah, they're trying to fill a bucket full of water that has a pretty big hole in the bottom. So it's not really going to work. We were talking about blockchains earlier, and the blockchain, the Bitcoin blockchain, is a 3D blockchain. I'm completely lost on this. What you told me earlier was the best, description that I've heard of it yet. Can you dumb it down a little bit so we can understand what a 3D blockchain is, and how is that really more secure than just a traditional blockchain?
So it gains its level of security by having checking and balancing. So just like the United States government was designed to have checks and balances of power, it's
designed to, but
it's we've seen the folly in many of those things. But the merit of the design is still the merit of the design. Maybe the implementation was just incorrect. So it has 3 levels of locking: level 1 and level 2 and level 3. Now you have a weight and a trust associated with you as a cryptographic identity. So if I am somebody that's constantly doing validating on the L1, I'm going to build up time, and that's going to basically increase my reputation. And increasing that puts the attack vector in time. So if somebody wanted to try to attack the network, they'd have to spend years trying to build up their trust enough to be able to manipulate the consensus. So the L1s, think of those as kind of parallel canals. The blockchain's kind of like a river, and it only has so much capacity. And as soon as there's too many transactions, you get backlog or backflow, and it dams up and it overflows. So what we're doing is, as the node counts increase, you'll be able to have parallel canals, right? So that transactions can be assigned to each canal, and then they can be processed in parallel. But the problem with that comes is if one channel, let's say, conflicts with another channel, and you don't have some sort of consensus mechanism in order to deal with those lock conflicts, then you degrade into kind of an easy to manipulate system. So that's where the L2 locks come in. So those are going to actually be checking every one of the canals and making sure that they don't have any conflicts with one another, and they're waiting with stake. And then obviously they have trust associated with that, which continues to build it. And then the final one is the miners, and then they check the L2s and then make sure that the L2s validated everything properly. And if somebody, let's say, tries to manipulate the consensus or go and create a false chain, it'll be easily detectable because you can see the main level of trust versus somebody else's lesser trust. And so you can create kind of a cost associated with that. You're not going to get that time if you're not with the consensus. So you solve the nothing at stake problem, or presumably solve it with the L2s. And then as the miners being the L3s checking the L2s, what they do is they weight the data further, but you still allow the benefits of proof of work without relying on the proof of work and without the miner being the complete dictator of the transaction. So think of it as just series of handoff, kind of like how the internet works, where when you make a connection, you go to the DNS service, which then resolves you an IP address, and then that goes to the local ISP's network, hops between main ISP routes, and then goes internally, and then it hits the router, and then it goes to your own internal network. And so the tiered scaling is how the internet has been designed to scale. So it's a similar type of concept because without parallel processing, things just simply won't scale. And if you try to do parallel processing with only one consensus method like side chains, what's going to happen is the security is going to degrade every single chain you create off on the side because there's less validators. And the security of a blockchain comes from the total number of validators or the total amount of computing power of the validators.
And what about the transaction time? Say, like with Bitcoin, it's what, 7 per second, or has that increased with SegWit? And what is the transaction time for Nexus?
Nexus can do 60 to 70 transactions per second as it stands right now. But theoretically, as we get the 3DC built, it's going to scale with the node count. So instead of having a software bottleneck like we have, where you have a limited block size, even if you have the node capacity, it's going to scale with the total number of nodes that are capable of processing for it. So I don't want to make any claims on any numbers on what it should be because it's still being engineered, but the architecture is being designed to be able to expand as it's needed.
So right now, Bitcoin and many of the Dash and the others are the main use case is currency, and that's they're looking obviously for many other use cases in the future. But
It's
for Nexus,
digital
are you envisioning use cases similar to some of the other digital currencies, just doing it better, or are you looking at new use cases, entirely new use cases, consumer application or commercial applications?
Yeah, a lot of that's outlined in the Tritium white paper if you guys want to take a read, but that kind of goes into our software stack. So you have the first level, which is your network level, and then the second level, which is your ledger level, the third level, which is the register level, fourth level is the operation level, fifth level is the actual API level, sixth layer is the logical, and then the seventh layer is the interface. So most consumer applications will be running on layer 6 and layer 7, and then they can interact through an API to make it easy to use. Now, we don't know every single use case, just like internet engineers didn't know everything that the internet would become. So what we're working with the stack is on the operations side and the API side, businesses to be able to come together in working groups and standardize and say, well, we want our supply chains to function this way, and we want private medical records this way, and we want to define this metadata for copyright formats this way, and so on and so forth. The sky's the limit. So we're kind of integrating a little bit of social technology in with the actual blockchain technology to kind of make that easier for consumers to adopt, and also to let us know the specs that we need to make it so that you don't design something to be overcomplicated and too generic. You make it more specific processing so each API functions for each specific industry and how they need, and creating a more collaborative spirit rather than a competitive one like we experience generally today.
So you're building a protocol and a platform and allowing other people to come in and whatever their creative minds can think of to build on top of.
Yeah, and to help standardize how it functions and what it does to make sure that what they want to build on top of it is scalable and usable.
Awesome. And so we're coming to break, and don't forget to come out tonight at the Monastery Bar and Grill. And what was that address again, Doug?
4810 East McKellips Road in Mesa.
And welcome back to the Digital Cash Evolution here on 1100 KFNX. Definitely give us a call here, and the producer will take your name and number, and you can get free money. I mean, who doesn't want free money? This is actual real money, not that paper stuff that they keep printing over and over and over. QE infinity. Oh my God, what is that? That's one thing that cryptocurrency solves. It's not printed endlessly. There's a finite amount. It's like gold. It's digital gold. That's exactly what it is. And there's also something else that we're going to be giving away. And it'll be actually in a couple of months. So what we're going to do is people that are getting these wallets and getting this free Dash and Bitcoin, we're going to put you into a drawing. And in about 8 or 10 weeks, we're going to give away a Ghost Gunner. I don't know if you know what that is, but it's a CNC milling machine that allows you to, well, make your own gun if you want. And this is perfectly legal. I think California is putting a kibosh on it on July 1st, but it is still legal everywhere else, other than, I think, North Korea and a few of these other places. So, yeah, this is going to be interesting. Go to ghostgunner.net and check out that machine. And if you're a Second Amendment supporter, like the creator of ghostgunner.net, which is Cody Wilson, then you might be interested in this.
Yeah, we got Theo Chinos chiming in here on our live stream here saying, this is an intangible commodity. Our good buddy Morpheus, who was prosecuted for doing illegal activity of trading Bitcoins.
But that's not
Theo
illegal.
Theo has supported Morpheus with that case, and Morpheus coined that term, and Theo's reminding me to say call this intangible commodity, which I think is a really good word for the type of what Bitcoin and what the cryptocurrencies are.
Another name that gets thrown around quite a bit is Aetherium. If anybody knows, any little bit at all about Bitcoin, they've probably heard about Aetherium. And Aetherium is trying to solve these smart contract problems. And since we have, Colin here, he's got a new white paper out that's connected to Nexus that wants to solve those problems even better. Colin, give us the rundown on what Aetherium is, what they're trying to solve, and what Tritium does.
So what Ethereum's been trying to solve is basically having, you could call it a distributed computer, where you can program on a specific language and then the state of any execution of that is recorded on the chain so that you have trusted execution models, I guess you could call it. And so they developed what's called the Aetherium virtual machine as the interpreter, and then Solidity and other languages as kind of the language layer, where you can program in a specific language and it's Turing complete, and it allows you to create tokens, or it allows you to do supply chains.
Can you give like a brief, simple description of what Solidity is?
Well, so Solidity is a language that is compiled into bytecode, or Ethereum virtual machine instructions. So a virtual machine is virtualizing what a computer already does. So when you make, let's say, a compiled binary, you have what does go into straight native operating system, or not operating system, processor level bytecode, which basically tells the processor, I need you to add these numbers, I need you to store in this register, anything else. The Ethereum virtual machine emulates that by having their own set of bytecodes. So Solidity is a language, a programming language that you would program in, and then you compile it, and it turns into native interpretive language for the Ethereum virtual machine that allows that to execute on the blockchain, and every node will execute that code and agree upon a certain state of all the variables within that after that execution, which allows you to basically program on a blockchain in a way that it can't be manipulated or changed.
So Ethereum actually started with Bitcoin on colored coins. And this was the idea where you could put assets, just tag an asset to a coin, and whatever coin held that asset, then that was your, proof that you own the asset or whatever. How did Ethereum kind of differ from that? And how did it move away from that, and what did it solve? Because I know, I guess Vitalik wanted to solve other problems that the guys that were developing colored coins weren't really interested in doing.
I'm not sure of that pass. I heard ties to Mastercoin or something like that as secondary protocols. But what I do know is from looking at their code that Bitcoin has a scripting engine in it. So it's designed to be programmable money. And it was deliberately designed not to be Turing complete. So it was limited in what you could do. You could use a certain set of opcodes, but then you had to program in that actual native language. It was not something that you could actually compile into. So Ethereum made it Turing complete, which means that it could do everything that a Turing computer could do. But the biggest power, at least what I isolated from it, is their ability to have contracts talk to one another and send data to one another. So what that happened is that allowed self-executing programs to exist as transactions, which then could be programmed in a higher level language like Solidity, which gave rise to the ability to create ERC20 tokens or any of their other token standards or CryptoKitties or other things like that to use it as, I guess you could call it a data storage truth box in a certain level and a processing truth box.
To give a kind of a simple description of what Ethereum was really meant to do, can you describe Slockit, like how that was supposed to work with Airbnb?
Oh, the DAO?
Yeah.
You're talking about?
Well, that failed, but I mean, it was a good idea.
Yeah. Yeah, it was.
I mean, kind of just give a description of what that was supposed to do for Airbnb. I guess your smart contract would activate the lock on a door.
I'm not necessarily sure about what Slock did. I know about the DAO, but I mean, having an authorization system where it could unlock the door, you could have something tied to a cryptographic identity and make a signature and then have that, let's say, lock communicate with the ledger to be able to prove that event happened. And you could do something similar to that. I'm not exactly sure about their architecture.
Right. I mean, lease cars, all types of different things could be operated by these smart contracts so that if you weren't paying on your car, well, your car would just shut off on you and they wouldn't need the software or whatever that the car lot's doing. It's just automatically, built into the initial purchase of the car. Let's get into what you're trying to do. What is it that Tritium is trying to solve?
So we're trying to solve the scalability of it and also the modularity of contracting engines. So right now, I usually use the analogy of think about a piece of gum. If you try to pull a piece off of it, you got all these strings attached. And it's really difficult to interchange pieces. Tritium is basically modular on many different levels, and we break up the stack just like the internet is broken up in a stack. It's not one big glom of code. It's different layers that interact with one another, and these layers of abstraction allow different developers of different types to make better decisions. So let's look at Slock.it in the DAO. The code is reviewed. They thought they were right, and then it ended up having a security vulnerability because it was just a simple deployed program. They raised a lot of money, and there was a lot at stake, and so somebody went and attacked it. And they may or may not have been qualified to write that. I can't speak for them, but based on the events that happened, it seems like they weren't. So when you have an overcomplexity and a lot of security based upon the system and you have it all abstracted as one layer, you create a lot more prone to error, and you also create a completely generic system that has a higher barrier of entry for people to be able to understand how to utilize. So by breaking Nexus up in the Tritium software stack into layers of abstraction, any different type of developer can get on different levels. Like we have Dino helping on the actual network level, which is on the IP layer with Lisp. And then, I'm working with some of my team on the ledger and the register level. And then we're going to be working with businesses and other very low level programmers defining the operation codes for the operation layer. And then businesses, of course, are going to help define the API layer and what calls they specifically want on top of that, so that when you're building a decentralized application, you're going to be able to interact directly with the API layer, and then all this stuff underneath is going to be doing what it's meant to do without an overcomplexity so that it scales, and then also with a high amount of testing and working groups based in it. So that's how the internet becomes what it is. It takes time for different protocols to be rolled out, and they have to be tested, and they have to be attacked in many different ways. And there's almost a vetting process for different documents where you get RFCs or ISOs. So in a similar type of way, we're doing that. Since blockchain is similar to the internet, we need to have a decentralized way to have the protocol standardized and move forward.
So you will, let's break that down into English. You're going to have more checks and balances than Ethereum.
Well, yeah, and it's going to be, how should I say it? It's going to be easier to integrate too, because like I said, there's this, at least my observation anyway, is that developers sit at this top and they say, we've built this and this is the future, and now you have to figure out how to use it. And then they may change things out from under businesses that are trying to build on it. And it makes the integration process very difficult. So we want to integrate those together. We want to have people be a part of it and be able to help tell us what they need.
How can people find out more about Nexus?
You can go to nexusearth.com or follow us on Twitter. Check us out on Facebook, NXS Earth.
Definitely check out Nexus and check us out at thecryptoshow.com. Hit us up on Facebook. The PhoenixCrypto.com.
PhoenixCrypto.com. And something fun on the side here. Phoenix Crypto just got a mascot, little baby boa constrictor. So we're doing a fun little giveaway. We're going to give away a Trezor, which is a Bitcoin hardware wallet and multi-crypto hardware wallet. Go to hashtag name the snake and give us your name suggestion. She is a female, so we're doing hashtag name the snake. The winner's going to win a Trezor hardware
And
wallet.
come out tonight at 6 at the Monastery Bar and
4810
Grill.
East McKellips Road.